What is Coriolis force? To understand the force, let's first explore how it works. First, we have an object rotating about a point relative to that point. Because it moves about this point, the acceleration acts in a circular direction. Here we can apply Newton's second law. The object's mass remains constant as the force is applied, so we can go ahead and solve for an expression for the acceleration. Due to the direction of motion, we have radial acceleration. This is equal to the change in v squared over the change in radius. We can also substitute angular velocity for the linear speed. After differentiation, we are left with Coriolis acceleration, 2 times the angular velocity times the radial velocity. With this, we then can form the equation for Coriolis force, which is simply just the mass times the Coriolis acceleration. Coriolis force is a fictitious force, meaning that it is only apparent from a viewer's perspective. To explain, we'll go through an example of what happens normally and what happens when the apparent Coriolis force is present. If we have a rotating surface with constant angular velocity and the object moves radially outward relative to that point, the object should move in a straight line in the direction of its radial velocity. Here, there is a different tangential velocity at point 1 and point 2. The tangential velocity of point 1 is equal to the angular velocity times the radius at point 1. The tangential velocity of point 2 is equal to the angular velocity times the radius at point 2. With this, we can prove that there is an increase in tangential velocity from point 1 to point 2. In the case where an apparent Coriolis force is present, there is no increase in tangential velocity causing point 2 to fall back, moving in the opposite direction of the rotating surface. This happens because the Coriolis force acts perpendicular to the velocity vector, causing the object to follow a curved path. To prove this, I practiced tossing a ball on a merry-go-round, and you can see that the ball follows a curved path opposite of the merry-go-round's direction. And that's Coriolis force.